guys! Today I'm sitting on the floor because I feel like it. So today we're going to be going over mass and weight, which we just went over in upper L, so I'm not sure how much you third graders are going to know about this, but I'm just going to tell you what I know anyway. So when talking about mass and weight, the easiest way to talk about it is basically with an object. In this case, if I'm talking about mass, the mass of an object is basically how much matter it's made up of. So for example, this plant is made up of a specific amount of matter. No matter what I do, I can't really get rid of that matter. It's not going to change. I mean, I could cut it up, I could rip it apart, but those pieces would still have the same amount of matter. That's just how it works. Weight, on the other hand, is more related to gravity. So for example, here on Earth, this plant has, I don't know, probably a weight of 2 pounds maybe. But if I had this plant with me up on the moon, it would probably be so light it could probably float. But if I had it on another planet, a denser planet, instead of being 2 pounds, it might be 200 pounds and be really, really heavy. The weight of an object can change depending on gravity, but the matter doesn't change. It's still, no matter where we go in the universe, it's still going to be made up of the same amount of matter, so the mass would not change no matter what. Same thing with me. If I go to the moon, then I'm going to weigh a lot less than I weigh here on Earth, and if I go to a really dense planet, I'm going to weigh a lot more than I weigh here on Earth, but no matter where I go, I'm still going to be myself, unless my arm gets chopped off. But even then, my arm, that matter still stays. It's just no longer attached to me. This is kind of morbid. So in the United States, we have, what's it called? The U.S. customary system. So like earlier, I was talking about weight in terms of pounds. So we use pounds, ounces, and tons. Other places in the world, they use the metric system, so they use like kilograms and grams. So we're going to kind of go over those today. I had a poster on the wall in the classroom that kind of showed the information I'm about to tell you, and I probably would have given you a printout, but since I can't really do that right now, I would suggest that you write down these units as I tell them to you. Maybe write them down on the back of your multiplication chart, or maybe write them down in the back of your journal, maybe somewhere where you can find it a little easier. Okay? So since we live in the United States, we're going to start with the U.S. customary system. Ounces, pounds, and tons. You probably remember whenever we talk about like gallons and cups and pints and stuff, we also have ounces there. Those are liquid ounces, and typically in weight, it's just regular ounces. But they're a little different, but they're the same thing. Basically, kind of, just a little different. They weigh the same. 1 pound is 16 ounces, and 1 ton is 2,000 pounds. So if someone tells you, my gosh, this weighs a ton, they're probably exaggerating, but what they're basically saying is, my gosh, this weighs 2,000 pounds. Remember when I told you to write down stuff? So I want you to write down that 16 ounces makes 1 pound, and 2,000 pounds make 1 ton. So some examples they give are a box of cereal could weigh 24 ounces. Some students might weigh 98 pounds, and many cars weigh 1 ton or more. So, number 1, Mallory's book weighs about 2 pounds. 2 pounds is how many ounces? 2 pounds is how many ounces? Well, we're basically just going to do 2 times 16, because we know that 1 pound is 16 ounces. 2 pounds has to be double that. So our answer is 32 ounces. So number 2, the rhinoceroses weighed 3 tons. 3 tons is how many pounds? We know that 1 ton is 2,000 pounds. So we're going to multiply 2,000 by 3, and we're going to find it is 6,000 pounds. And that's basically just how U.S. customary system works, essentially, yeah. Now we're going to move on to the metric units. Like I said before, the metric units are grams and kilograms, and usually in other places in the world, they use them for weight. But they are also used around the world and in the U.S. to talk about mass. So again, I would like you to write down that 1,000 grams equals 1 kilogram. Kilo means 1,000, so that might be a way to remember. So gram is just a gram, and then kilogram is 1,000 grams. A dollar bill has a mass of about 1 gram, whereas this big textbook that I use has a mass of about 1 kilogram, probably. Maybe a little bit less because this book isn't actually 1,000 pages and each page is about a gram, but it's, let's see, how many pages are in this book? But it is 817 pages long, so that's, you know, close enough to 1,000. So it's basically a kilogram. So for this next question, I'm going to give you a second because I want you to guess, and then I'm going to tell you the answer because there's not really a way for us to work through it. For this question, I'm going to give you some options, and you're going to choose which is the more reasonable measure. So for A, a pair of shoes, would it be more reasonable to say that a pair of shoes is about 1 gram or 1 kilogram? I'll give you a second to think about that. So it's more reasonable to think it is 1 kilogram because, again, 1 gram is basically the weight of a dollar, or the mass that a dollar has, and shoes are obviously heavier and have more mass than a dollar bill. B, a cat. Is it more reasonable to say that a cat is about 4 grams or about 4 kilograms? Did you say kilograms? Because if you did, you got it right. C, would it be more reasonable to say that a quarter is about 5 grams or about 5 kilograms? 1 quarter. 1 coin of a quarter. It's 5 grams. 5 grams would be, yes. Then number 4, Dolores's rabbit has a mass of 4 kilograms. 4 kilograms is how many grams? Recall that 1 kilogram is 1,000 grams. Her rabbit has a mass of 4 kilograms. That means we're going to be multiplying by 4. So our answer is 4,000 grams. Okay, and I just checked the work for lesson 77. I'm going to tell you right now with number 30, what it's asking you to do, it wants you to divide by 6. I'm just going to let you know that right now, just because it's worded a little bit weird. That could potentially be really confusing just because of how it's written. And I would also like all of you to try early finishers for this lesson. At least try it out. If it's too confusing, don't give yourself a headache over it, but it looks to me like you'll be able to do it. I think it's easy. I know I'm the teacher, so I mean, it's supposed to look easy to me, but All right, so go ahead and let me know if you do need any help on anything, and I'll be around. And yeah, so lesson 77. I will see you tomorrow. All right.